starting at exactly 8:10. That is like 16 minutes from now. Get ready, get your book, get your notes, get your questions. We start. Good morning, and how are you at this particular day? I want to welcome you to our chemistry lesson, which is carbon and its compound. It's our second lesson today. So yesterday we had the introduction part of the topic, and we were able to see or to discuss on the allotropes of carbon. We looked at the pure allotropes of carbon, which we said it is diamond and the graphite. Now today we are going to check on the chemical properties of carbon. That is, how is carbon able to react with other elements or even with other compounds like the acids. So, welcome to our lesson. Welcome to Ambassador Speaks YouTube channel, where we nurture growth. Everybody who has never subscribed to our channel, Ambassador Speaks, so we ask you to do so. We request you to do so. For those who are returning, like you've been there for all these days, we will say thank you for all those. And for those who maybe it's their first time, I would welcome you and ask you not to miss in any of our lessons. So what am I saying this morning? Let's look at chemical properties of carbon, and of course together with other properties. Now, the first one is the combustion, like burning of carbon in air. You know, the symbol for carbon is C. Now, this carbon, when it is burned in air, what happens? Air contains very many components, yes. It has nitrogen, it has oxygen, it has carbon dioxide, it has, water vapor, but the active part of air is the one that will react with the carbon, active part of air. The active part of air is oxygen. This is the one that is going to react with the carbon. I want to start by asking whether all of you can see what I'm writing on the board. I want to ask whether you can hear me. Of course you can hear me, because that one I would have seen someone complaining. But let me ask if there is anyone, if you can see what is being written on the board. So let's look at now the chemical properties of carbon. Number one, combustion, burning of carbon in air. This one, it is simply like reacting carbon with oxygen. That is, in fact, that is the property number one. It burns in air to give carbon dioxide. But I'm going to write two equations. The first one is this. Carbon is a solid to react with oxygen, which is a gas, to give us CO2, which is another gas. Black, colorless, colorless. And of course, for you to score a mark in a writing of chemical equations, there are four things which you must fulfill. One, make sure you are using the correct symbols and the correct chemical formulas, of which in this case, it's very fine. So in fact, you will see, for the 5 or 6 equations that we are going to write today, we have to confirm all these. Now, from there, we have to see whether that we have given the correct state symbols, solid, gas, and gas. If you put L here for liquid, then you would have gone against it. And you risk, just writing a chemical equation is only 1 mark. So, and most of the examiners will, if you make one mistake, they will fault you completely. Like, they will not give you half a mark. Now, after that, you check if you have the correct products, of course, because sometimes you can write the correct reactants to give us wrong products. Lastly, you ensure that it is well balanced. Like the number of atoms of a certain element on the reactant side should be the same or equal to the number of the same atoms of that particular element on the reactant side. So that is how it is. That's the first equation showing the chemical property of carbon when it's being burned in air. Now, this equation applies when oxygen is in excess. Yes, you get carbon dioxide. Now, ask yourself, what will happen if the oxygen is limited? Like, now, we have carbon, which is a solid, plus oxygen gas, and it is limited. What will you get? Because you will not get CO2. You will get the lower oxide of carbon. This is the higher oxide of carbon. CO2 is the higher oxide of carbon. Now, carbon and oxygen, when it is limited, you will get a lower oxide of carbon, known as carbon 2 oxide. Carbon 2 oxide, that way. It's also a colorless gas. And this is the one that is actually poisonous. CO is poisonous. CO2 is not poisonous. CO is a pollutant. CO2 is not a pollutant because it is part of the naturally occurring air. Like even if you go to a forest where the air is very, good, you will still find a certain percentage of CO2, but not CO. Now, this equation is not okay. Like ukiangalia vizuri, yes, we are only done with two parts. Three. We are done with giving the state symbols, one. We are done with writing the correct elements and formulas of the compounds formed, that is CO. We are done with giving the correct products, of course. Then lastly, it is not balanced. Like carbon here ni moja, carbon on the other side ni moja. So carbon is okay, but for oxygen, it is 2 here. And on the other side, the oxygen is 1. So meaning you have to place 2 here. By placing 2 there, you balance the oxygen, but you destabilize the carbon. So by placing 2 here, it makes carbon 2 on the reactant side. So you have to come back here and place 2 to balance. Now, this equation is very okay. So that is one of the chemical properties of carbon, that it burns in air to give the oxides of carbon, depending on the amount of oxygen. Limited, you get CO. Excess or enough, you get CO2. Now, still on CO2. CO2 when you are in, I'm checking whether it is, I have to cross-check whether what I'm writing is feasible. And of course, I can see it is very much feasible. So what I'm saying is that this CO2, in Form 1, you are told that if you want to know that a certain gas is CO2, like confirmatory test for carbon dioxide, this one is the one that you pass through lime water or calcium hydroxide. It gives or it forms a white precipitate. So we can write an equation like CO2 gas to react with calcium hydroxide. Calcium hydroxide. What is the state symbol for calcium hydroxide? It's aqueous. Now, in this case, we are bubbling, or you, okay, the best word is you are bubbling CO2 gas through calcium hydroxide. The reaction will be in such a way that a white precipitate will be formed. And we must be there to explain what is this white precipitate by the use of equations. The white precipitate is calcium carbonate, which is a solid, then plus water, which is liquid. So I'm seeing if it is feasible. Now, is that equation balanced? Like, are the number of atoms of a given element on the reactant side the same as on the product side? This one you can easily check. Like C Ningabi 1. On the other side it is still 1. So oxygen we have 2 plus 2. this 2 is for this oxygen and it's for this hydrogen still. So we have 4. On that side, still oxygens are 4. Calcium is 1, and of course, calcium is 1 on that side. Hydrogen is 2 here, and hydrogen is 2 on the other side. So we can say that the equation is very well balanced. Let me also explain this, that now, when you purple CO2 through calcium hydroxide, it is going to form a white precipitate, of course, which is a white substance. Now, in fact, you can write down here white. Use how for those who are writing the equations. Yes. Now, if you continue bubbling CO2, like now CO2 in excess, the white precipitate dissolves and it forms a colorless solution. That means, like now, after these products have been formed, calcium carbonate plus water, you continue bubbling CO2 gas. So it is like now, you have calcium carbonate here, which is a solid, plus water. I'm just bringing the products there. Now, I add more CO2. It will give you a colorless solution. My question is, what is that colorless solution that is being formed over there? So it's going to be calcium hydrogen carbonate. Calcium hydrogen carbonate. Calcium into bracket hydrogen carbonate. Then place 2 there. It is aqueous, colorless. So we are there. Ask yourself whether it is. The laptop is. Ask yourself whether it is balanced. Calcium is 1. Calcium is 1 pale. Carbon we have 1, 2. Carbon pale tuko na 2. These 2 is for everything here. So carbon pia ni 2. Oxygen we have 3, 4, 6. Oxygen we have 6 on the other side. Then hydrogen 2, hydrogen 2. So the equation is very well balanced. Where are you watching me from? That I forgot to ask you where you are watching me from. Samuel Maina anasema good job teacher. Samuel, share with your students. Tell them to join this particular lesson. Join. At least we keep ourselves busy. Like those who are in my site, you can realize that it is very cold. So ingia online to some chemistry kidogo. So what am I saying here? That was the first property, like it was a property on combustion. Nimekupea 2 na nimekupea pia venye oxygen, so carbon dioxide can react with calcium hydroxide. And this is the confirmatory test for CO2 gas. Great. Nataka tuingie property ingine inaitwa reducing property of carbon. Yes, carbon. No, not carbon dioxide. Reducing property of carbon. I want to get a text from you. Where are you watching me from? Like, which place? Allow me to check on the guys from the shifting grades if they have any comment. Then nimekuwa biased. I was only checking on the comments from my side. So let me check on the comments on the shifting grades. Like, what are they saying? Yes. We have Pashwa TV. Anasema nice work. Learn with me. Kenya Fisipo. Pashwa anasema anatoka Kitale. David Alex from Nairobi. Then we have somebody known as Learn with me. Oh yes, it's coming out from Tika. So I'm saying, tell me where you are watching me from. Of course, it's just to keep us in momentum. Like, where are most of my viewers coming from? So I want us to look at another property, and that is the property. Mukuha Gladwell anasema from Nairobi. Thank you. Sasalimia watu wa Nairobi na msiende maandamano. Daga tuone kitu inaitwa reduction property, to reduce. From Canada. Hey. Kevin To. Sawa. Salamia Mikuna huko Canada. Mwambie wa Kenya wanakupenda akuja tuambie FIFA Revolution. Sawa. Shifting Crates is watching us from Nairobi, Kenya. Good work, sir. Nairobi Westlands, ngoja waje nisikuingilie hiyo story share. Maira Modoni, thank you my student for joining me in this. Now, let's look at this. Reducing reduction property of carbon. What does this mean? Can a carbon reduce another compound? In this case, most of those who have not reached form 4, the kind of reduction I'm talking about is the reduction of oxygen. But once we are in form 4, the kind of reduction we will be talking about, apart from the oxygen one, is about the electrons, gaining and losing of electrons. When oxygen is taken from a substance, we say that other substance or species has been reduced. The one taking the oxygen is said to be oxidized. Now, in form 4 electrochemistry, when you gain electrons, we say you are gaining electrons to be reduced. When you lose electrons, we say you are oxidized. Why? Because when you lose electrons, your oxidation number increases as per the number line. When you gain electrons, your oxidation number decreases. For example, I'm sorry to start this, lakini I'm just tempted. Like, for example, look at this. Look at magnesium. Magnesium solid, oxidation number yake ni 0. When it loses electrons, it may lose electrons, inakuwa ion, inakuwa magnesium 2+. Oxidation number yake inakuwa +2. Between 0 and +2, which one is having a higher oxidation number? +2. So it lost the electrons to be oxidized. In baadaye, tutaangalia baadaye. We shall look at on when? Monday morning. For those who will not be going to school, we will be looking at electrochemistry, the whole topic, electrochemistry. Now, let's look at what you call, kuna watu wanasema, shifting rates, anasema, shifting rates is saying, let's also purpose to follow Sir Alex through his YouTube channel, Ambassador Speaks, thank you, on YouTube. So let's look at this point. There's something I want us to discuss kidogo. I want us to look at the reducing property of carbon. Carbon is reactive than other metals. Now, if they come into contact, and of course, when the other one is having oxygen, carbon will take away the oxygen from it. Let me do the first one. Let's start with copper 2 oxide. It is written as CuO. Now, if you have CuO, this one is a solid, and it is black in color. Sawa? Now, to react with, or to come into contact with carbon, which is a solid, which is also black in color, please be very keen with that. If carbon is more reactive than copper, then we will have a reaction. Like, there will be a reaction proceeding here. We are going to have CO2, which is a gas, plus copper metal, which is a solid. And this one is brown. But, for example, if we have sodium oxide plus carbon, in this case, there will be no reaction. Why? Copper is below. So why am I saying copper? Carbon is below sodium in the reactivity series. You and your elder sister, akiwa na remote ya TV, it is very difficult for you to take it. Ukiwa nayo, atakuja, achukue remote, and on top of that, anakuwekelea slap. Na hata shtuki na ameenda. So, ndio hii sasa. Now, in this case, that is a reducing property of carbon. Like, you must be able to accompany observation. This one is a colorless gas. By the way, nimeamua kuanza na chemical properties so that after this I will give you the physical properties of CO2. Actually, I was supposed to start with the physical properties, but there is no problem with that. Now, this equation is not complete, of course. This equation needs to be balanced. Yeah, it needs to be balanced. Like, ukiangalia vizuri, the number of the carbon atoms on this side may not be equal to the number of, it's not making sense. Aya, so angalia hapa. Kopa ni ngapi? Kopa ni moja. Na ni moja huku. So tumazana na stories za kopa. Lakini hatuwezi mazana because kuna mahali pia itatushika. Carbon ni moja, oxygen ni mbili. Oxygen ni moja. So we will be forced to place 2 here. Kopa ikuwe mbili. Enda weke 2 pale. Then now it balances. Now it's very well balanced. Now, nataka nikupe ingine moja. Lead oxide plus carbon. Lead oxide plus carbon. Lead oxide solid plus carbon, which is a solid. And the question is, of course, we know carbon is black. This one is yellow. This is black. The condition here is there should be heat. The same as here. Heat must be accompanied. In fact, during exam, they can omit heat. Then unaambiwa state the missing conditions. You will have to talk of it must be heated. Heated activates the reaction and enables carbon to take away what? The oxygen. So in this case, we are going to have lead solid. Lead is gray. This is gray. Plus CO2, which is of course a colorless gas. Then from there, you simply balance by placing 2 upper and here. Yes. Angalia vizuri uone kama kuna if there's a problem somewhere, but I think all in all it is functioning very well. Aya, bado tutaandika zingine mbili. We are still discussing on the chemical properties of carbon. We are on reducing property. Let's talk with zinc oxide. I'm also writing this so that you get to know the colors of the oxides. Yes. Ndaga tuende kwa zinc oxide. Zinc oxide. Zinc oxide is white. And it's white and when hot and when cold, you will get that. So zinc oxide solid plus carbon solid will give us zinc, which is a solid, plus CO2, which is a gas. So this one is white. And this is of course black. What's the color of zinc? Most metals are gray. Most metals are gray except copper. We have this one, which is a colorless gas. Then the condition here is lastly, nataka tufanye ya iron 2 oxide. I hope you can see down here. Solid plus carbon solid will give us like hebu niangalia hapa kama hapo chini inaonekana ama haionekani. So will give us iron, which is a solid, plus CO2 gas. So let me not write, but just know that this one is brown. Iron 2 oxide is brown. black, gray, colorless. That is it. So the ability of carbon to remove oxygen from other metals is said to be a reduction, while itself is being oxidized to carbon dioxide. Yes. Yeah. Any question as we are moving to the next one? I wanted to give you the reactivity series of elements. Uone venye iko. Nitakuandikia tu hapa kidogo, like it's not all of them. Wacha nifute ubao, then I will write for you, starting with potassium all the way to platinum. Anyone with a question? Okay, nobody is having a question. Chaniangalie watu wangu wa shifting grades wanasema nini. Wao pia hawana kelele. Sawa. So let's look at the reactivity series. Which one starts? Which one? Like in the metals. Okay, I'm not going to capture all the elements, but the most ones that we always use. So we have here, and take up potassium, sodium, calcium. Of course, when writing, try to be thinking of their chemical families. Then put here magnesium, put here aluminium. Now, a non-metal here comes in, which is carbon. Carbon, which is now the interested element. Then we have zinc ion. Zinc. We have iron here. So now, carbon cannot reduce the ones above on it. Then we have tin. Tin is Sn. Then we have the lead, Pb. By the way, most of you have, don't come into contact with Sn. Sn is a tin. Then here we have another non-metal, hydrogen. Hydrogen pairs tuliona in our previous topics, like water and hydrogen. We saw how hydrogen could reduce some metal oxides. Yes. Then we have copper. Copper inaandikwa hivi, Cu. Then we have silver, Ag. Utaona kweli? Ag. Then we have gold, then platinum. Gold is Au. Platinum is Pt. I doubt whether you can. I hope you can still see it. I hope now you can see. So that is the order. Most reactive, least reactive. Up there is the most reactive. Down here is the least reactive elements. Yes. Somebody is asking a question. What is the color of lead oxide when hot and when cold? Then learn with me and say red. Cold when yellow. So yes, learn with me is very correct. The two colors, that is red or orange, is or are accepted. Yes, thank you for that. Yes, that was the order. I would like us to look at another property again, which in this case, it's going to be our third property. Did you know that carbon reacts with steam to give us carbon 2 oxide and hydrogen? You want to get your equation from your side? Carbon, steam. to give you carbon dioxide and oxygen. Yes. Ndio nifute hii kenye kwa ubao. Nataka tuandike equation ya carbon and steam. But I'm giving you a minute, you write on it, then we write together. Yeah, so I believe the 1 minute I've given you is enough for you to have written that particular equation. Equation. Yes. Aya, carbon. Steam is gas. Don't make that mistake of writing liquid. Will give us CO, a gas, plus hydrogen gas. Now, kuna kitu inaitwa water gas. Water gas. Water gas is a mixture of CO and H2 mixture. Name two gases that comprise the water gas, CO and H2. Hope we are okay from up to that point. Tin is SN. You mnajaribu kuleta hiyo, achana nayo. Confirm from the periodic table. Yes, so now we are moving to other properties. Andika kwanza. Now I want us to write another chemical property. Carbon and acids. Carbon and the mineral acids. We are going to start with carbon and nitric 5 acids. Yes. Tumezoea metals and acids. Now let's look. Carbon and the acids. I can wrap this if everything is okay. Someone anasema, please pardon. I don't know where exactly do I need to pardon, but you can just write there what is that you want me to pardon. I will do it very fast. I will pardon it very fast. Puni combustion in nini? I will check on it very fast. Now, carbon plus nitric 5 acid will give us gases and liquids, which is water. So we have carbon here plus HNO3, which is aqueous. No, not aqueous. Concentrated. By the way, whenever you see acid ikiwa aqueous, ujue hiyo ni dilute. Ukiona ikiwa L, ujue ni concentrated. Now, it's going to give us NO2 gas. By the way, NO2 is known as nitrogen 4 oxide gas, and it is brown. Brown in color. Plus, of course, kama tuko na NO2, then tuko na carbon. What comes to your mind? There's another gas formed, which is CO2. Then we have hydrogen now remaining, and still kuna oxygen to give us water, liquid. Now the big thing here is balancing the equation. I don't want us to go through very many steps of balancing the equation. you will know how I've balanced it. I want you to place 4 here. Weka 4 kwa nitric 5 acid, weka 4 kwa hapa, then weka 2 kwa mwisho. It will balance. It's going to balance. Now that is the first equation. Now this is a property, reaction between carbon and the acids. Yes. Ya pili, you can write, I will give you some seconds to write, carbon plus sulfuric 6 acid. Carbon to react with it should be liquid. It only reacts with the concentrated ones. It only reacts with the concentrated ones. So I'm waiting for you to. As I'm explaining something about lavender, be writing this equation. In fact, I will give you one of the product. One of the product is sulfur oxide. The rest in fanana na huku. Lavender is saying that I should repeat on the reaction of the water gas. I said water gas comprises of 2 gases. That is carbon 2 oxide and hydrogen gas. And water gas is formed when carbon reacts with steam. Carbon plus steam. Steam is water in a gaseous state. Carbon and steam reacts to give water gas. Yes. Now, I hope we are together, Lavender, about that one. Ya pili, I hope you are writing the equation. Let me check my other channel if they are doing well. Ama wanasema nini? This ni ndogo sana. I'm from Lovey Boys, Mandera County. Oh, salamia watu wa Mandera. Thank you so much. Claudio anasema red, brown. You choose one color. In chemistry, you don't write a mixture of colors. You just decide with one color. Which one to work with. Red is allowed. Brown is allowed. That's why I wrote brown. I cannot write red, brown. That one shows that you're not sure. Okay, whoever was writing the book, I'll take a red, brown, because if you look at the nitrogen oxide very well, you will be seeing some red and brown fumes. But when writing in an exam, you write one, decide one, work with one. Even chlorine is green, yellow. Like there are some traces of green color and traces of yellow color. But when writing, you deal with one. You work with yellow or green. Don't mix the two. What am I saying here? Deal with brown or either red. I think I'm okay with that. Now, let's write the equation of this. Like carbon plus H2SO4. And take up sulfur oxide. And then the rest remains the same. So this is going to be SO2. Nataka unibalancie. I want you to balance for me. And if you are coming in right now, tell me where you're watching me from. And who is your chemistry teacher. So I request all of us to follow Ambassador Speaks YouTube channel. We have more than 300 videos there for chemistry, for physics, and for talks, on academic talks that matters in your life, that makes you be a better person. Now we are there. Can you balance that equation? This one? What do you place where? Just like the third one, you can place 2 here, place 2 here, then place 2 that point. Hebu angalia kama imebalance. Kama bado uniambie unataka tuweke nini wapi. Tell me what you want us to place where. Is it in order now? I think it's in order. So as you are confirming if it is balanced, and also confirm if you have any question as we are moving on. Now, those were the chemical properties of carbon. I think we have written several of them. Is it how many now? To Mandek, I think almost 10 equations. So I hope next time when you ask about a reaction between carbon and anything else, you will be knowing how it happens or what it happens. We are still writing more as we are moving on. I want to introduce about carbon dioxide. We have, the name of the topic is carbon and its compounds. So we are only going to check on two compounds here for today. That is carbon dioxide and carbon dioxide. We are going to see on how it's being prepared. Then we will see some physical properties of carbon dioxide. Our time will be up because we are supposed to end at around 9 or 9:10 there, and then from there we will be doing fine. So what am I saying? Yeah, if you're okay with this, I can wrap it off. Those who are joining us, welcome in. Nataka tuone. By the way, we never discussed on preparation of carbon because it occurs naturally. So, but CO2, we have to learn how to prepare CO2 because it doesn't occur naturally. And I'm only giving you one. In fact, I'm explaining to you how it's being prepared. And yours is to listen to me. I will only write a chemical equation. Like, if you want to prepare carbon dioxide, you need the following. You need a carbonate. You need a carbonate and the acid. Carbonates react with acids to give salts, CO2 gas, and water. Now, the one that has been proved to yield more CO2 is combination of HCl, and it should be dilute. Of course, it is always dilute, and calcium carbonate. These are known as the marble. So that's the best combination. As you are choosing the combination, also ensure that you are choosing the one that do not form insoluble salt. Like in this case, if you take H2SO4 like sulfuric acid to react with this, you will get a very small amount of CO2 gas. Why? Because the salt formed here, which is calcium sulfate, is insoluble and it prevents further reaction. I hope there we are very clear. Now, what's our equation over there? It's calcium chloride, CO2, and of course, water. CO2 gas is produced, and of course, water. Now, if you want the gas, of course, there is a diagram, which I cannot draw it right now. It will take much of my time. And I don't know if I can show it using a laptop, where it's going to be visible. No, it cannot show. I think it is full of light. Unless nipunguse lights, lakini sasa waje tu nikubali ya kwamba aitamake. Anyway, there's no problem about that. So what I'm saying is in the first column, it has several conical flasks. In the first conical flask is where the reaction between HCl and carbonate takes place. In the second column, we have sodium hydrogen carbonate. And you have to explain what is the role of sodium hydrogen carbonate in that case, because it has, or it must be having a function. In the third column, it has concentrated sulfuric 6 acid. Then, lastly, now is our dry carbon dioxide gas. First of all, which method are we using to collect CO2 gas? That one you must tell me, because we have several methods of gas collection. Tuko na ngapi methods of gas collection? Tuko na downward displacement of air. Tuko na upward displacement of air. Number 3, tuko na over water. Number 4, tuko na using a syringe. Yes, so hii ya mwisho, all gases can be collected using a syringe. Is it feasible? You know, I may have tampered with some settings. Mayra, can you see what I'm writing on the board? And Lavender, can you see this? Yeah, so number 4, using a syringe, all gases can be collected using a syringe. Whether it is denser than air or less dense, whether it is soluble in water or insoluble in water, it can be collected using a syringe. Now, over water, only those which are insoluble, but we don't say insoluble, we say slightly soluble. Slightly soluble. Slightly soluble in water. For example, oxygen. Yes. Then we have upward displacement of air. Upward, like if it is upward displacement of air, it is being delivered downward. So the other name for upward displacement of air is downward delivery. This one is applied when the gas is denser than air. Then we have this downward displacement of air, meaning it is upward delivery. It should be denser. Sorry, less dense. Less dense than air. Now, an example of, okay, in Mesema, all gases can be collected using a syringe. Over water, an example is oxygen. Upward displacement of air that is now denser than air. These ones, we have example of CO2 itself, then chlorine. Downward displacement of air, that one we have an example of nitrogen. Hydrogen, not nitrogen. Hydrogen. Yes. Good. Now, our CO2 gas is collected by downward delivery because it is denser than air. Now, wacha niangalie kama kuna swali on the side of shifting rates. They're saying land with Kenya and over water for oxygen. CO2 is soluble in water, so we cannot use over water. Okay, but okay, it is also not highly soluble, but it is soluble. So if you collect using downward delivery, and I collect using over water, you will have more CO2 than I will have. It is, or a given percentage will dissolve in water. Yes. To give us weak carbonic acid. You understand? Now, let's look at this. Niko na swali kama 3 nne hivi. Swali ingine tu ni ya form 1. Like, from that particular setup, I wish I had drawn before I started the lesson, but it will take time right now if I start drawing. What is observed in a beaker containing HCl and calcium carbonate? Like you have calcium carbonate in a beaker and HCl. What is observed? Here is calcium form 1. Very simple, vigorous effervescence occurs as CO2 gas is being released. Question number 2. You are told to write an equation for the reaction. Do we? So malizia tu vizuri, sema it should give you calcium chloride, which is aqueous, plus CO2 plus water. Is it balanced or not balanced? Hydrogen ni mbili, hydrogen ni moja. Chlorine ni mbili, chlorine ni moja. So simply weka tu hapa. It is highly balanced, or it is well balanced. Swali ya 3 inauliza explain the purpose of sodium hydrogen carbonate. I told you after the first conical flask yenye iko na calcium carbonate and HCl, the second flask that comes that comes next contains sodium hydrogen carbonate to remove traces of HCl gas. Where we have where we have HCl acid, there must be traces of HCl gases, hydrogen chloride gas. So sodium hydrogen carbonate removes traces of HCl gases. Yes. Then why is it being passed through concentrated sulfuric 6 acid? It is passed through concentrated sulfuric 6 acid to dry the gas if the gas is needed dry. So it is a drying what? Agent. Yes. Drying agent. Niko na swali. Now that tumesema we have said that H2SO4 liquid is a drying agent. What is the alternative? Like, I will not answer you unless someone answers me for the comment section. What is the alternative of this? Like, we don't have H2SO4. What else can we use to dry the gas? Yes, I'm waiting for you. Niangalie, what is the alternative? Nione watu wa shifting grades. By the way, shifting grades is a very nice. It has been there for quite some time. Leo hawataki kunijibu leo watu wa shifting grades. Niko na shida gani? And the way najivunia kuwa na shifting grades. Nasemanga shifting grades. Hamtaki kunijibu? Aja. Melvin anauliza calcium chloride. He's also asking me a question. Na mimi ndio nimeuliza swali. Melvin. Mkuu anasema sodium hydroxide. Sodium hydroxide. When did sodium hydroxide started being a drying agent? Nani, who is this? Mukua. When did sodium hydroxide started being a drying agent? I just want the alternative. I'm not going to jibu. Because of time, I will proceed because sioni mtu anataka kunijibu. Alternative, the gas produced, listen here. The gas produced is acidic. This one is acidic gas. That is acidic what? Gas. Being acidic gas, so the drying agent, so first of all, you remove anything that is basic. So remove anhydrous calcium oxide. So here, we will use what we call anhydrous calcium chloride. So who is right? Melvin, we cannot use calcium. You are right. Your first answer was correct, Melvin. Here, pili achana nayo. It is anhydrous calcium chloride. Ukiandika calcium chloride, walai, bilai, hautapata. Tumeelewana? Yes. Thank you. Now, niko na swali ingine. Hii hata sitaki hata to discuss sana, lakini I'm just saying, which other combination, by the way, give me a combination of an acid and a carbonate that can be used to produce CO2 gas. Make sure kuna exceptional gases that we are not supposed to use, especially that the ones that will give us insoluble salt, like calcium sulfate. Avoid that one. So everyone who has enjoyed the lesson today, Mukuha, tutakuja kukosana na wewe. Wachana na hiyo kitu unasema. Your answer is correct. The first one. That is anhydrous. Ngoja. Oh, ilikuwa Melvin, but Melvin pia amefuta. Anhydrous calcium chloride, yes. So, avoid combination of the ones that will give you insoluble salt. Tumeelewana? Yes. Now, everyone, because we are almost finalizing the lesson, give me a combination of an acid and a carbonate that can be used to prepare CO2 gas. Haya, nataka nimalizie. I was just checking on one two things here. Haya, wacha niangalie machama wangu wa shifting grades. What are you saying? Do you have any combination? Oh, repeat the question. I'm saying this. I've given you one way of preparing CO2 gas. That is hydrochloric acid to react with calcium carbonate. Give me other pairs or other combination of an acid and a carbonate that will give us CO2 gas. Avoid a combination that will give us a insoluble salt. I'm fine there. I think you can now answer me. Are you together? Yes, so in fact that is the question I'm waiting for. Ndo tumalizie siku ya leo. Then we meet in the evening at what time are we meeting in the evening? We are meeting in the evening at exactly 5. Tuichape kasi kidogo, like tupike shughuli kidogo, to discuss to discuss something kidogo. Tumalizie linear motion. Melvin amesema H2SO4 and magnesium carbonate. Very nice. It will give us magnesium sulfate, CO2 and water. Nice. Hawa majama wangu hawataki kunini kujibu hii swali. So in short, I'm saying this. Any combination can give us CO2. But if the salt produced is insoluble, then it will give a very small amount of CO2. So avoid that one. Otherwise, I would like us to stop there for today. I want to thank you for joining our lesson. I want to thank you for also bringing more people, more guys to Ambassador Speaks. Ensure that today you bring 2 or 3 people to this particular channel. Be a blessing to this channel. Bring more guys. See you in the evening at 5 for physics lesson. Thank you.